Hello my dear students, welcome to the class of 11th English Medium. The subject is Statistics, Chapter 3, Measures of Central Tendency, brought to you by Vitan Sir. Previously we completed the topic of geometric mean, which you can find on the top right corner of your screen. This time we are starting with the positional averages. Yes, the first type of averages were the regular averages, or I named them observational averages, which were arithmetic mean and weighted and combined and geometric means. This time we are starting with the second type. Those are positional averages. If you want to know in detail the types of positional averages, you can just go to my very first video on the top right corner of your screen. I am going to start with the first positional average, that is median. The first positional average is median. Let us understand what is median. The value of the middlemost observation when data is arranged into either ascending or descending order, that value is called median. That means when we arrange our available data into either ascending order or the descending order, and the value or the observation which is in the exact middle of the given data, we call that median. So we can say that 50% of the observations are below the median value and the remaining 50% of the observations are above the median value, because the median is at the exact center. That means our data is distributed into two equal parts. Now remember this statement I made: the median distributes or divides our data into two equal parts. This statement will be useful in the future, so remember this. And the median is denoted by capital M. Let's see how this median is calculated. The formula for calculating median, starting with the row or the ungrouped data. Now when the data is row data or the ungrouped data, we need to arrange the data into ascending or descending order, and after arranging them into ascending or descending order, we use this formula for median: the value of the n plus 1 upon 2 observation. That means the total number of observations plus 1, and because it is in the exact middle, that is it divides the data into two parts, we divide these observations with 2. Because it divides the data into two parts, n plus 1 divided by 2, and whatever is the number of observations which we get, we can either start from the beginning or we start from the end. We calculate that number of observations, and when we reach at this median number of observations, the value of that observation is our median. I will explain this concept through illustrations, but let me just complete with the list of formulas first. The next formula is for classified or grouped data. Now, of course, there are two types. The first one is the discrete frequency distribution. Now, a discrete frequency distribution has the observations and the frequencies with respect to the observations. So, what we get is that n is the total number of observations, that is total number of frequencies, that is sum of frequencies, that is sum of fi. So this time when we take n, it will be the total of all the frequencies. Now using frequency distribution, we calculate our cumulative frequency. Yes, the second chapter topic, the cumulative frequency, if you don't know, just go to the top right corner of your screen. That concept we are going to use in this calculation. So we will be calculating cumulative frequency using the frequencies available, and then the formula will be the same what we did in the previous. That means the value of n plus 1 upon 2th observation. But after calculating that, that particular observation is found using the cumulative frequency. That's the concept here. That also I will be explaining in detail in the illustrations. Now that observation will be checked in the cumulative frequency column. Okay, so I will explain that in the later sums. The second part of the classified or grouped data, that is continuous frequency distribution. Now, for continuous frequency distributions, we don't have direct values, we have the classes. So, they are usually arranged into ascending or descending order, and therefore after finding the cumulative frequency for the given classes, median class is found. That means once we calculate the cumulative frequency, we have to find the median class. That means the median might be or maybe in this particular class, because class does not give us exact value. So we need to calculate median class as class with the value n upon 2 observation. So in the continuous frequency distribution, we don't take n plus 1. In the raw data and in the discrete frequency distribution, we took n plus 1 divided by 2. But in the continuous frequency distribution, we directly take n upon 2. So don't mistake it. We have to take n upon 2 in the continuous frequency distribution. So the observation which is n upon 2, so the class which has that particular observation becomes the median class. Okay, so after calculating median class, we have to calculate the total number of observations, that is n, which we are going to use in the calculation is sum of fi. And then now the formula for calculating median in the continuous frequency distribution is m is equal to L plus n upon 2 minus Cf divided by f into C. Quite a long formula, but let's see with what is the meaning of these symbols. L is the lower boundary point of a median class. So the median class has a lower boundary point, that is L in this equation. Then Cf is the cumulative frequency which is above the median class. That means the median class has a cumulative frequency, and the cumulative frequency which is above this median class, that we have to use in the calculation. Then we have frequency of the median class, that is f, and C is the class length of the median class. So the class length of the median class, the frequency of the median class, the lower boundary point of the median class, and the cumulative frequency which is above the median class. These things we are going to use in the calculation of median for the continuous frequency distribution. But in this tutorial, I am only going to show you some illustrations based on the raw data. In my next tutorial, I will be explaining you the illustrations based on discrete and the continuous frequency distribution. So you will have to hang tight for that. Right now, let's start with the illustrations based on the raw data. Illustration 17. The numbers of items produced by a factory in different weeks are 80, 85, 90, 92, 68, 80, 72, 63 and 55. We have to find the median production. Now, as you can see here, the total number of observations are 9, and we need to arrange these observations into ascending order. Now, ascending means we have to start with the minimum value and end with the maximum value. So once you check out the data here, the ascending order will be like this: 55, 63, 68, 72, 80, 80, 2 times 80, that is 85, 90 and 92. Now once we have got this, we can start with our formula, that is median, the value of n plus 1 upon 2 observation. Okay, as we know, the number of observations here are 9, so we will replace n with 9. So 9 plus 1 upon 2, that would be 10 upon 2, that would be the value of fifth observation. Now we can start from either side, but we have to go towards the fifth observation. So 1, 2, 3, 4, 5. From either side you calculate the fifth observation, the value is 80. So that means the value of median is 80. Okay, I hope you guys got this properly. The fifth observation, that means you have to count the number of observations from either side because it doesn't matter, that is value 80. Okay, so just write the statement, thus the median production of factory is 80 items. Got it, guys? Let's move forward to the next illustration. Illustration 18. The daily profit of a hawker in rupees for last 10 days is given below. Find the median profit. Okay, the data is some in whole numbers and some is in the decimals. So what we need to do is we need to arrange this data into ascending order. So it will be 249, 255.5, 257, 258.5, 260, 261.5, 262.5, 264, 265, 267. And the number of observations here are n is equal to 10. So now we will again take the formula median n plus 1 upon 2 observation, that would be 10 plus 1 upon 2 observation, which would be 11 upon 2 observation, and it will give us in the decimals 5.5 observation. That means it is not fifth observation and not sixth observation, but this observation is between fifth and the sixth observation. So when this kind of situation arise, we just need to find the average of the fifth and the sixth observation. Because this is 5.5, it is between 5 and between 6. So we need to calculate the average of the fifth and the sixth observation. So the fifth observation plus sixth observation divide by 2. A simple mean, a simple average we are going to calculate here. The fifth observation, as you can see, is 1, 2, 3, 4, 5, that is 260, and sixth observation is 261.5. So we need to calculate an average between 260 and 261.5, which will be 260.75. That means if I write a statement here, the median daily profit of hawkers is rupees 260.75. So when your observational answer is in decimals, that is in 0.5, you that is 5.5 or 6.5 or any number, you just need to find the average of that number and the next number. So if it is 5.5, then 5 and 6. If it is 6.5, then 6 and 7. It is very easy to calculate, nothing difficult there. Moving on. Illustration 19. There are 11 employees in an office. The monthly salaries in rupees of the lowest paid 7 employees among these are 4500, 2100, 3400, 3600, 2500, 4200 and 1500. What is the median salary of all employees? Okay, now we have to calculate the median salary of all the employees here. So how we are going to do that? First of all, the lowest paid 7 employees are given. That means the remaining 4 employees are the highest paid employees. So the highest paid employees we will assume as A, B, C and D in the ascending order, of course. So suppose 4 employees with highest salaries are A, B, C, D. So now we arrange the given data into ascending order. The lowest paid 7 employees will be written first and the highest paid ABCD will be written last. So we will arrange them as 1500, 2100, 2500, 3400, 3600, 4200, 4500 and ABCD. Okay, so the last 4 observations are unknown to us, but the remaining 7 observations we already know. And the total number of observations, that is the employees, are 11. Now we will use our regular formula of median here, the value of n plus 1 upon 2th observation, that would be 11 plus 1 upon 2 observation, 12 upon second, that is 12 upon 2th observation, that would be the 6th observation here. So as you can see, the remaining ABCD does not matter, we just need the 6th observation, which would be 1, 2, 3, 4, 5 and 6, 4200. So the median monthly salary of all the employees will be rupees 4200. As you can see, we calculated this sum without 4 of the available observations. So that is one of the advantages of the median, that we can calculate median without all the observations. We just need some of the observations to calculate it. Before I complete my tutorial, let us see the advantages and the disadvantages of the median. Starting with the advantages, it is easy to calculate and understand, as we have seen from the illustrations. It can be found by inspection. That means just by looking at the ascending or descending data, we can estimate that what will be the value of median, which is not so with the mean. It can be located by graph. If we draw a graph of the frequency distribution or the data, the middle part of the graph could be called the median. So we can calculate it using by graph. It is the only option when distribution is open-ended. Open-ended means the lower limit or the upper limit has no limit. At that point of time, the only option available is median, because mean and mode both need a complete set of observations. Median only needs the middle part. The remaining part could be anything at all. It is less affected by too large or too small observations, as too large observations will be at the end of the class and end of the data, and too small observations will be at the beginning of the data, while median calculates what is at the center. It can be calculated even when certain data is missing, just like in the latest illustration I taught you guys, the ABCD data was missing. Still, we could calculate the median salary of the employees using the central value of the data, which was actually there. So when certain data, the beginning or the end data is missing, we can still calculate median. And then comes disadvantages. It is not rigidly defined. That means its definition is not that rigid. We may be able to interpret it otherwise, or we may say that it is loosely defined, a very general definition, the value which is in the middle. It could be anything like. So it is not rigidly defined. It is not based on all the values, which is one of the disadvantages according to the characteristics of an ideal measure of central tendency. It is not suitable for further algebraic calculations. That means using median we cannot calculate further. That's end. After median nothing comes. It is less stable than compared to mean. So these are the disadvantages of the median, and I hope you guys understood what is median actually. Next time I will be discussing the discrete and the continuous data, calculating median for that kind of a data. Okay guys, so I hope you guys enjoyed this tutorial, and giving a sub to my channel will be very good. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel, and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.